Next, we're gonna go to one of our highlighted talk from Francis Chan. I believe that no need for introductions for Francis. He is a long time our good friend, dearest friend, I have to say. Professor Francis Chan is a world-renowned clinician scientist in gastroenterology, and currently he serves as a director of the Center for Gut Microbiota Research at the Chinese University of Hong Kong. He's gonna talk about young at guts, role of the gut microbiomes in healthy aging and anti-aging. And I believe that last year you mentioned that when we use the microbiota treatments, the baldness is going to be full of hair. And after your talk, I believe that we're not only young at gut, we're going to be young at face, all right?
Thank you, Rutherford, for your very kind introduction. And I would also like to take the opportunity to thank Professor Mahachai and the organizing committee for asking me to come back to this wonderful symposium. Today, my talk is about young at guts. What do I mean? Before I go into the details, this is my disclaimer statement. I'm sure you all agree with me that we are facing a global aging problem. In Asia, right now, some countries in Asia, the percentage of the population above the age of 60 is 30% at least, and this will continue to grow in the next 10 years. About 7-8 years ago in the Time magazine, the editor has put up the face of this baby and come up with a very provocative statement. He said, this baby could live to be 140 years old. At that time, we all laughed, but now I guess we dare not to laugh so loud. This might be possible. The problem is not about longevity alone. It's about healthy aging and, if possible, anti-aging. I'm sure there are many factors contribute to aging or healthy aging. Today, I would like to focus on the role of the gut microbiome in this whole aging process. To make life simpler, in the field of gut microbiome, when we talk about aging, people would like to focus on the role of gut inflammation in aging. Now, using this oversimplified diagram, you can see that, in fact, inflammation in the gut, people call inflammaging nowadays, can contribute to inflammation in our brain, leading to aging, what they call immunosenses. Now, start with point number one. Where there's a chicken or egg phenomenon, we know that there are age-related declines in intestinal function. Now, this may be the consequence or may be the reason behind the ordered gut microbiome with aging. Now, with this change in gut microbiome and also with the changes in the intestinal function with age, there will be increase in the inflammation in the gut. And there are data showing that with this gut inflammation, that would lead to inflammation, demyelination, and changes in our brain, leading to a lot of other age-related problems, which I will come back to you later on. Now, one important question people often ask, in terms of the gut microbiota, what is the difference between the gut microbiota for a young, healthy adult versus someone who is old but healthy versus someone who is old but unhealthy? Now, on the left-hand side, with this blue square, this is the typical gut microbiota of a young, healthy adult. It consists of two major features. Number one, the mucus layer is very thick, as shown by this yellow box. At the same time, the core microbiota of a young, healthy adult consists of a lot of bacteroides. Now, this bacteroides, on the one hand, it degrades the gut mucus, our intestinal protective layer. On the other hand, because when we were young, we were able to replenish our gut mucus layer. So despite having a lot of bacteroides as our core microbiome, our gut remains healthy. In a way, it can also help increase the turnover of the gut mucus. Now, what about when we get older? What's the difference between someone who is old and healthy on the upper hand or upper right column versus who is old but not healthy on your right lower column? Now, the difference is, first of all, you can see that no matter you are healthy or unhealthy, with age, our gut mucosal mucus layer will thin out. There will be thinning of the mucus layer, regardless of you're healthy or unhealthy. But the main difference between a healthy old elderly versus an unhealthy elderly is the core microbiome. You can see that for someone who remains healthy when they get older, the core microbiota changes with less and less bacteroides, less core microbiota. Whereas for those who remain unhealthy when they get older, their bacteroides persist over time. Now, if I show you the next slide, this is the main changes or the secret for those who are getting older or those who become extremely old. When we get older, you can see that the core microbiota, as shown by the yellow circle, is shrinking. At the same time, the so-called subdominant variable fashion, these colorful tiny circles, they're getting more and more. So far, people working on this field, they believe that with longevity, there will be, number one, shrinkage of the core microbiota. Number two, there will be acquisition of longevity-adapted, these tiny little colorful circles. So these are the secrets of those people who are very old and probably healthy. So the question is, what are these tiny little colorful circles, this longevity-adapted subdominant fraction? If I refer you to this box on the right-hand side, you can see that for those who are very old centenarians, comparing to the healthy people, they have got a lot more verrucomicrobia and Actinobacter. These are what we call the longevity-adapted good microbiome. At the same time, they've got less bacteroides, and the fabricles remain more or less the same. Now, what is the impact of having healthy versus unhealthy microbiome in our guts, and how is it going to affect our central nervous system in terms of a cognitive function? Now, I want you to focus, first of all, on the left-hand side, the green one. With an intact, healthy intestinal barrier, I'm sure we all understand that the good microbiome will produce short-chain fatty acids, maintaining the mucus layer, and therefore there will be minimal inflammation in the gut mucosa, maintaining a healthy immune cell function. And with that, therefore, the blood-brain barrier, everything, the myelination, ramified microglia, they will all in a healthy state with minimal inflammation. In contrast, if for any reason this mucosal barrier is being disrupted, then the bad bacteria will produce less short-chain fatty acids and lead to disrupted immune cell function. This will in turn lead to crossing of these inflammatory mediators across the blood-brain barrier, leading to a lot of sick consequences such as demyelination, microglial activation, and cognitive decline. These are the hypotheses largely based on animal studies. So you may ask, what are the mediators of the gut microbiota that lead to cognitive decline? Now, these mediators that can be, number one, produced solely by the gut microbes. Number two, they can be produced jointly by the gut microbe and our human body. And third, they can be just metabolized, converting the human products by the gut microbiome. Now, for the first two on the upper hand column, these are the specific bacteria unit metabolites, including the short-chain fatty acids, the exopolysaccharides. They are also combination of products that are shared by the bacteria and a host, such as on the left-hand side, the polyamines, which is either from our diet or is kind of de novo biosynthesis. And also, we have got some products that are being modified by the bacteria, such as conversion from the primary to the secondary bile acids. Now, you may ask, how these metabolites affect our longevity, our healthy or unhealthy aging? Well, there are quite a number of studies showing that these metabolites, such as the butyrate, cholic acid, or the spermidine, they affect our longevity based on epigenetic changes, microbial changes, and also autophagy. Again, these are all based on laboratory, cell-based, or animal studies. How this would translate into the human features, we are not sure yet. Certainly in clinical practice, we often ask this question, what is the real age? I look at Professor Mahachai, she always looked young to me. How come someone like her can maintain such a young-looking face, and vice versa? So, in fact, there are different ways to measure our biological age. Theoretically speaking, these are the 4 different ways. People can talk about, you can assess your biological clock by measuring your gut microbiome diversity. More diversified sounds better, but there are other ways that may be more precise. For example, we can assess the taxonomic clock, meaning whether you have certain good bacteria signifying young age versus those who are harmful to our body, such as Campylobacter jejuni. Certainly, we can also measure the so-called functional clock of the body, whether you've got good metabolites maintaining our good immune functions, such as the short-chain fatty acid producing amino acid metabolism, or whatsoever. Last but not least, we also can measure the metabolomics, such as the various metabolomics which would affect our aging process. But that being said, these are largely for research purpose. I don't think we can use any of these clocks in clinical practice to judge your real age. Now, regardless of the real age, I believe what we really want to do is, if aging is inevitable, can we really stop the aging clock or even reverse the aging clock? This is something that we want to answer, this $6 billion question. Now, earlier on, I have shown you this schematic diagram about the importance of gut inflammation in relation to decline in the cognitive function due to immunosenses. If we believe in the role of gut inflammation that in turn would affect our cognitive function, then in fact people are trying different ways, such as trying to restore the gut microbiome with prebiotics, probiotics, or symbiotics. Even they are in the commercial market coming with new medicines. They call them senolytics, or things that can reverse the inflammation in the gut, or xenomorphics. Now, all these commercial products, they all sound very attractive. Unfortunately, none of them appear to have any solid clinical or laboratory evidence to support their efficacies. Now, I'm sure we all understand that the importance of food. There are so many, if you go to the website, anti-aging superfoods available in the market. Now, being a Chinese or many Asians, these food, we know they are good, but they may not be all kind of fit in our usual appetite. For example, I don't eat salmon that much, and a lot of Mediterranean diet, we all know they are good, but it's not for me. In contrast, certain Asian food, like the food from Japan, they are all very good. So people, we all know that Japanese, a lot of people, they've got very long life and also good quality of life. So what are the secrets to Japanese longevity? I'm sure Professor Sugano is here, he will be able to tell us a lot more. But at least recently, there's one interesting study from Kyoto, one of the prefectures in Japan, where there are a lot of elderly, healthy adults. And according to this study by Dr. Naito, they found that the use of soy products is associated with frailty among the older community residents in that prefecture. So those who are not frail, they tend to have a high intake of soy products. So I'm sure there's a lot of secrets behind soy products. Whether it would change your gut microbiome, I understand that Dr. Naito's group is doing a lot of interesting ongoing studies. Now, what about fecal microbiota transplantation, FMT? There are animal studies and also human-to-animal studies suggesting that FMT does improve certain parameters, such as improving the physical fitness, the health span, even lifespan, and also reduce this census-associated secretory phenotype, suggesting that FMT may be something quite exciting as an option for healthy aging, if not anti-aging. And some people even advocate that we take out your own unhealthy gut microbiome, do kind of genetic manipulation and put it back into our body, hoping that we can reverse the microbiome clock. This all sounds very, very attractive. But the real question is, does reversal of the gut microbiome clock really desirable? Now, I showed you early on about the age-related changes of gut microbiome. The real question is, will turning back of this microbiome clock be really desirable? Earlier on, I mentioned that for the young healthy gut microbiome, the core microbes are bacteroides. Just imagine if we try to put back the young healthy gut microbiome, mainly the bacteroides, into our body. If you believe in this theory, it would do more harm than good because the bacteroides will destroy our gut mucus layer. The thin gut mucus layer among the elderly is actually will get worse by putting in this young gut microbiome. So reversing the microbiome clock is not that simple. So therefore, I just give you an overview of the kind of advocates and challenges of reversal of the human gut microbiome when we become old. This is really challenging if ever possible. But we all know that, in fact, the first 3 years of life are really the window opportunity in which we can change the gut microbiome, whether we want to make it healthy versus unhealthy would have important consequences on our subsequent life. So instead of just working on those elderly gut microbiome, should we at the same time put a lot more emphasis on the early life gut microbiome, which is a lot more amenable to manipulation. And because of that, in Hong Kong, about 5-6 years ago, we established this work we call the Microbiota Eye Center or the Magic Center. And our team consisted of quite a number of people from different areas. We really want to focus on the area of early life gut microbiome in order to bring health and hope to our new generation. So we built on not only conventional R&D research, but also we have established a huge live data platform with the use of notobiotic animal facilities and generative AI. We come up with something quite interesting that I can share with you. For example, in the last 5-6 years, we have established this big cohort we call the mummy cohort, which is really looking into how the gut microbiome in early life affect our future. So in this mummy cohort, which consists of multiple centers in Hong Kong and mainland China, we started collecting prospective specimens and clinical data since the first trimester, not only from the mother, but also we collect information and specimens from the father, and we follow these people up to the age of 7 after birth. And so to date, we have collected quite a sizable number of families, newborns, biological samples, and clinical metadata base, and doing a lot of this sample analysis. I would like to welcome other colleagues in Asia and other parts of the world to join this big prospective cohort. So to share with you some of the important findings. For example, during the period of COVID-19, we found that COVID-19 pandemic actually lead to delayed maturation of the microbial age, as shown by the yellow line, comparing to those who were born before COVID. Now, what is the importance of having this delayed maturation of the gut microbiome during the COVID period? One important consequence is that babies born during this period, they have a 46% increase in the incidence of allergies, such as asthma and eczema. So we have done further analysis, was partly related to the excessive use of disinfectants, which destroy not only the bad bacteria, but also the good bacteria, affecting the maturity of our immune system. The other important aspect is the gut-brain axis. Autism is not only a problem in China, but in different parts of the world. We are seeing an increasing number of children with autism. And over the years, we identified that among the newborn, we followed them prospectively. Those who develop autism, they have a delayed maturation of the gut microbiome, as shown in the lower panel, compared to typically developing children. And because of that, using this meta database, we're able to identify a multi-kingdom and functional panel of gut microbiota markers for the autism spectrum disorder. And last year, we have received the FDA Breakthrough Device Designation, hoping that we will be able to turn this panel of markers into commercially available diagnostic kits for early diagnosis of autism. At the same time, we also found that using this mega database, those kids with autism, they tend to have a deficiency in the GABA in the gut that would lead to sensory hyperresponsiveness and anxiety. And with that, we try to develop a novel symbiotic formula to counteract this gut GABA deficiency. And to cut the long story short, using this open label pilot study, we were able to demonstrate that by replacing the right combination of microbiome, we were able to reduce clinical anxiety and reduce this sensory hyperresponsiveness among these kids with ASD. And at the same time, we are now doing this preclinical development of live bacterial consortia. Our aim is to transform bugs into drugs in the future. Now, Mr. Chairman, ladies and gentlemen, I want to tell you that this was me at the age of 15, and this was me at the age of 50, when I kind of received one of my first invitations to Japan to give a talk. After the talk, I tried to enjoy something to relieve my nerves. And I took this picture a few months ago. So I guess we all have to agree the fact that we all age. But let your age go old, but not your heart. Thank you so much.